Okay, today we're going to be talking about the water and the water cycle. Round and round it goes. But first we need to learn about water. Water exists in three forms or phases: solid, liquid, gas. In terms of being a solid, we talk about the molecules closely packed together and they vibrate in place. Okay, there's going to be no movement, they're stuck there. They can move. An example as related to water is ice. We know it's a solid, the molecules are closely packed together, but they can vibrate in place. Liquid, particles that are attached, but they can move past each other. So there's movement now taking place between the liquid, but the molecules are still joined with other molecules. They're not individuals yet. Obviously liquid as of water. Okay. Gas, particles that are individual water molecules, they can float wherever they feel like going. Example for this is water vapor. Water vapor we see when it comes off of a pot of boiling water. The steam rising from the top there, that's gas. That's your water vapor. If we're going to take a look at examples of what this looks like in a chart, a solid again, our particles are compacted close together. They can vibrate in place, but they can't move. Our liquids, they're still attached, but they can slide past each other on either side. Where our gas molecules are actually going to be individuals and they are free to roam wherever they feel like going. The water cycle, what we deal with, is a variation of the three forms in which water can take. Start of the water cycle, you can start either way. It's a circle. It can go forward, it can go backwards, but the whole start of it is evaporation. Evaporation is the change from water being a liquid to a gas. In this picture, we're taking a look at water molecules as a liquid. Okay, close together, they can slide past each other. Turning into a gas, individual water molecules rise up. You know, warm gas rises because it's less dense. Another way that we can see water exchanged outward into the atmosphere is through transpiration, which is a process by which plants lose water out of their leaves. If you don't water your plants, they end up wilting because they're going to transpire. Like you sweating, a plant sweats through transpiration, you sweat through perspiration. If we were to put a bag at the end of a leaf, collect the transpiration, you'd see a collection of water at the end. What do you need in order for evaporation to take place? Think about putting out the stove. What is a stove? The stove is hot. Whether you get it from the sun as solar radiation, whether you get heat from a campfire, a stove, or just the heat in a room, that can also heat up, which causes evaporation. You standing outside on a hot day and you begin to perspire, the perspiration off you is going to evaporate eventually. The heat's going to get to it, change it from a liquid to a gas. Condensation, on the other hand, is the change of water from a gas to a liquid. So now we're going from that water vapor back to a liquid. Whether it's on the plants, as you see it do in the morning, whether it's on the outside of a glass of cold water, or it's on the mirror in your bathroom after you take a hot shower. What do you need in order for condensation to take place? The opposite of evaporation. You're going to need a cold surface of some sort, or the cooling of the atmosphere. We know in the troposphere, as you go up in altitude, that the temperature gets colder. So as water vapor rises, it's going to cool down, it's going to condense. That condensation, the condensing of the water vapor in the atmosphere, is where we get our clouds from. Your condensation takes place, no, the water did not travel from the inside of the glass to the outside. There's warm, moist air on the outside. As it comes in contact with the cool glass, it's going to condense. Condensation is going to take place and we get the water droplets on the outside. Once we have that condensation take place and we form our clouds build up more condensation, and they get heavy. And after they get too heavy, we end up with precipitation. Precipitation is any form of water that falls to the Earth's surface from clouds, whether it be snow, freezing rain, hail, or just rain itself. Again, any form that falls from a cloud is precipitation. Once it falls from the clouds, it's not immediately absorbed by plants in the soil. What tends to happen is that we have runoff. A flow of precipitation after it has hit the ground ends up in rivers, lakes, streams, aquifers, and oceans. Aquifers are just underground lakes. Water comes down too fast, it's going to stay on the surface, and we get those flash flooding. You'll see it on really heavy rain days. The gutters start to overflow. Okay, that's runoff. Water on the surface until it gets down to a lake, or again, any of the above. If given time, as soon as the water hits the ground, runoff will slow down, and eventually we get percolation. Percolation is the cause for liquid, for example, to pass through a porous substance or small holes, a filter. You can think about this as a coffee filter. You have to put a coffee filter in the coffee maker, you put your grounds in there. When the water goes through the coffee grounds, it percolates down into a nice cup of coffee. You're not eating the grounds, you're drinking the coffee. Same thing with soil here. The water comes in. If you water your plants, you'll see that all of a sudden the water trickles down, down, down. That's percolation. That's it trickling through. It becomes a natural filter. As it goes through the soil, it's getting filtered out. It ends up back in the groundwater or the lake or anything below it. So, in conclusion with the water cycle, in order for evaporation to take place, we need heat. Here's the sun rays. It's heating up the ocean. When we heat up water and change it from a liquid to a gas, we call evaporation. As we travel up in the troposphere, we know that it gets cooler, so the gas is going to cool off. And what's going to happen is that as the gas cools off, the liquid, the water vapor is going to condense on tiny dust particles all around, floating in the atmosphere, which becomes a condensation nuclei, and we're going to form clouds. Once those clouds condense enough, we have too much saturation of those clouds, eventually it's got to come back, and it's going to fall as precipitation. Whether it falls as rain or as snow, it all depends on the temperature of the atmosphere during that time. Again, once it falls to the ground and it hits the surface of plants, trees, what have you, it becomes runoff along the surface. As time goes by and that runoff slows down, water is able to seep back into the soil or percolate down into the bottom into an underground aquifer, underground lake down here, or just the water table back into the lake that it started from.